Hello and welcome to the lesson. In this lesson, I'd like us to go through curve sketching. When you're sketching a curve, you simply need to draw a rough drawing, which includes only important details, as you're going to see. Curve sketching does not involve the use of scale, so you're not supposed to do this one accurately. There is a process that you're supposed to follow when you're sketching the curve, and this is very important. 1. Find where the curve cuts the coordinate axis, that is, where the curve cuts the y-axis and the x-axis. For example, for the y-axis, if you want to know where the curve cuts the y-axis, simply substitute x with 0 and you get y. Y represents where the curve cuts the y-axis. For x-axis, put y is equals to 0 and then you solve. You will get where the curve cuts the x-axis. 2. Find the stationary points and determine their nature as done in the previous section. When you're doing curve sketching, we have an assumption that you have already done stationary points. You know how to find the stationary points and determine their nature. That is, whether they are maximum points or whether they are minimum points, or whether they are points of inflection. These two processes are very important when you are sketching the curve. Let's go to the example. Sketch the graph of y is equals to negative 3x squared plus 12x plus 15. So the first thing is to determine the axis, where the curve cuts the axis, that is the y-axis and the x-axis. So if x is equals to 0, then y is equals to 15. So this one shows where the curve cuts the y-axis at y is equals to 15. Then if y is equals to 0, if you substitute y with 0 in this function, you'll get negative 3x plus 12x plus 15 is equals to 0. And this will give you where the curve cuts the x-axis. This one is a quadratic equation, so to solve it, you simply divide everything by 3. And you know how to solve a quadratic equation. You simplify it, and when you simplify, you factor out using factorization, and you'll get these two solutions. So the curve cuts the x-axis at x is equals to 1, negative 1, and x is equals to 5. So therefore, we can conclude and say that this graph cuts at 0, 15. 0, 15 is where it cuts the y-axis. We got it here, 0, 15. We got it here, that is 0, 15. And then for the x-axis, we have 2 points where it cuts the x-axis. The one is, remember, when y is 0. When y is 0, x is negative 1. So negative 1, that is how we get negative 1, 0. And then when x is equals to 5, y is 0. So negative, these are 5 and 0. So these are the 3 points. The next thing is finding the stationary points. And you know how to find the stationary points. Stationary points occur where the derivative of that function, that is dy over dx, that is the derivative of that function, is equivalent to 0. So what it means, you're going to take that function and you differentiate it. When you differentiate, you get, this is the derivative. So when you differentiate that function, we just go back. The function we are differentiating is this, y is equals to negative 3x squared plus 12x plus 15. Assume that you already gone through how to differentiate this function. If you differentiate that one, differentiate y with respect to x, you'll get negative 6x plus 12. So you equate it to 0. At stationary point, the derivative is equivalent to 0. That is dy over dx is equals to 0. So once you get that, you get 6x, you solve that equation, 6x is equals to 12, and you get x is equals to 2. So this curve has a stationary point at x is equals to 2. So if x is equals to 2, what about y? Because we need to get that stationary point. So what is y? So for you to get y, you simply take the equation of that function. The equation of that function, it is here, y is equals to negative 3x squared plus 12x plus 15. Then you substitute simply substitute 2, x is 2, and you get that one is 27. So when x is 2, you get y is equals to 27. So you've just taken that x is equals to 2, and then you have substituted it in the function. So that is the stationary point. Now, draw the nature table. You want to determine now the nature of the stationary point. Is it a maximum point or a minimum point or a point of inflection? So this is what you do. You have to have 3 points. At the center there, you'll have 2 as the stationary point. Remember, the stationary point occurs at x is equals to 2. Then you can choose, there are 2 methods. You can choose, you put the stationary point at the center, then pick a point to the right of 2, another point to the left of 2. So you're filling this one using this function, dy over dx, the derivative. Remember, the derivative is here, is negative 6x plus 12. That is the derivative. So you can pick a point to the left of 2, for example 1. So substitute 1 in this function, the derivative, that is dy over dx. So let me just put it here, say 1 there, and you'll notice when you substitute that, this will give negative 6 plus 12, that will give positive. So negative 6, then x is 1 plus 12, this one will give 6. So this only 6 is positive. So that one gives positive. Then we already have, when you substitute 2 in that function, in this derivative, you'll get the derivative as 0. You already have that. Then pick a point to the right of 2. You can pick, for example, 4. And pick 4. So substitute it here. Negative 6 times 4, that is negative 24. Plus 12, that will give negative. So you can see the negative is there. So these 3 points will help you determine the nature of this stationary point. So now you can draw. So it is positive. That arrow shows that it's rising. It is positive, like that. And then that one is 0, stationary point. It is at the center there at 2, 0, stationary point. Then negative means it is moving downwards. So that is how you sketch it, and you determine that one to be. That one will be, if you sketch that, that will be a maximum point. So there is another way of determining. That is just one way. The other way is by taking the second derivative. If the second derivative, you get it by this. That is the second derivative. If you get the second derivative, this is the first derivative, negative 6x plus 12. If you differentiate again, you get now the second derivative. So if you differentiate this one, you get negative 6 and plus 12, that is 0. So you see that you're getting negative. So if you get the second derivative as negative, then that one becomes maximum point. I repeat that. I can write it here. If the second derivative is equals to negative, then that one is a maximum point. That is a maximum point. If the second derivative is positive, then it becomes a minimum point. So this one is just another way. And we have already established, without even having the 3 points, that when you get the second derivative of 6x plus 12, you get it to be negative. That is the maximum point. So after that, now we can sketch the curve. We have the axis. We have determined the points where the curve cuts the axis, and you have the stationary points, and you have determined that it is a maximum point. Now we can sketch the curve. So it cuts the x-axis as negative 1 and 5. We start by putting that. Negative 1 and 5 are there. So negative 1 is here and 5 is there. Then we go to the y-axis. It casts the y-axis as 15. The y-axis at 15. So 15 is there. So that is why we have 15. And we have the maximum point, stationary point. Remember the stationary point, we got it as 227 in the previous work that we did. So use that. So you put it there. Just a sketch, not accurate drawing. So it will be somewhere there, 227. And then with those points, you can now sketch your curve. We have the axis where it casts the x-axis, where it casts the y-axis, and then we have the stationary points. Those are enough for you to sketch the curve. So that is the point, 227. And then from there, you simply sketch the curve. So that is simply how you sketch the curve, by just using the there are two processes: getting the axis, where the curve cuts the axis, and then the stationary points. We can go to the second example, where you're supposed to sketch the graph of y is equals to negative 2x squared into brackets x minus 4. So the first thing is getting the axis, where the curve cuts the axis. And we start with the y-axis. It cuts the y-axis when x is 0. So when x is 0, y will be 0. If you just substitute where we have x in that function of y, where we have x, you put 0, substitute with 0, you get y to be 0. So that is the first point. Then when y is 0, now you're getting where it cuts the x-axis. This one will give a quadratic equation. If you factor out these, negative 2x into brackets x minus 4, this one will give either negative 2x squared is equals to 0 or x minus 4 is equals to 0. So this will give 2 points. It cuts the x-axis at 2 points. X is equals to 0 or x is equals to 4. So the graph cuts the axis at 0, 0 and 4, 0. Where did we get these? Remember, for the y-axis, when x is 0, y was 0. That is where we got 0, 0. Then for the x-axis, when x is 0, we have this point. When x is 0, again, why we have that? Actually, we have that. That one is a repeated point. Is a repeated point. When x is 0, again, y is 0. That is a repeated point. That is why we don't need to put it again. And then the other one, when x is 4, y is 0. Remember, y is 0, x is 4. Y is 0, x is 0. So these are the 2 points where it casts the axis 0, 0 and 4, 0. Now let's go to the stationary points. The stationary point, we get it by first differentiating. Remember, we say the stationary points occur where the derivative of that function is equivalent to 0. So we start by differentiating that function. So differentiate y is equals to negative 2x squared into brackets x minus 4. So you can start by opening the brackets and you get negative 2x squared, negative 2x cubed plus 8x squared. Then you differentiate that. When you differentiate that with respect to x, you get derivative, that is the dy of dx, to be negative 6x squared plus 16x. Now we said at stationary points, dy over dx is equals to 0. Now we continue. So once you solve that, you will get negative 2x to bracket 3x minus 8. You are factorizing, is equals to 0. So you get negative 2x is equals to 0. Let me take you back where we started. We stopped at this point. Negative 6x squared plus 16x is equals to 0. So you factorize what is common. Negative 2x is common. So you factorize and you get negative 2x is equals to 0, or 3x minus 8 is equals to 0. So you get x is equals to 0 and x is equals to 8 over 3. Those are the values of x at which we have the stationary points. Stationary points occur at x is equals to 0, and x is equals to 8 over 3. Now we should get the corresponding y values. So when x is equals to 0, if you substitute in the function of the curve, x is equals to 0, y will be 0. So if x is equals to 8 over 3, then y will be, you just substitute in that function of the curve, and you get, this will be 512 divided by 27. So therefore we have these 2 points. The stationary points are 0, 0, that is 0, 0, and 8 over 3, and then 512 divided by 27. These are the 2 stationary points. You write them in coordinate form. Now we can have this table of values. Just we said that this is just one of the methods. So the first stationary point is 0. You need to get a point, 1 point to the right of that, and 1 point to the left of that. Then we have 8 over 3 is another stationary point. Get the point to the left of that and to the right of that point. So then you're using the derivative to get the corresponding y values. So you simply need to substitute. So what you need to do now, in this derivative, remember the derivative is here. This is the derivative. This is actually the derivative. That is the derivative. So this is just factored out. I'm using it because it is still the same. So if you get 1 point that is to the left of 0, let's say -1, and substitute it here in this derivative dy over dx, you get your answer as negative. Then if you substitute 0 in that derivative, you'll get 0. That is a stationary point. Then you pick a point to the right of 0. Let's say you can pick a point like 2 or 1. And when you pick it, you substitute it in that derivative dy by dx, you get positive. So that one already has given you the nature of that point. Then you continue. The other stationary point is 8 over 3. Remember that one? If you substitute in that derivative function, get 0. Then pick a point to the right of it. You can pick even a point like 5, as long as it's to the right, and you'll get that one to be negative. You pick 5, a point that is to the right of 8 over 3, any point that is to the right of that, and then you substitute that one, that x value, in this function, derivative function. So that is what you get. Remember we said we have another method of determining the same, and that is the method of getting the second derivative. But first we can sketch this curve using this. So negative means we are moving downwards. Then the stationary point is straight there. Then positive means you are moving up. That one is a minimum point. And then the stationary point is 0. Then negative, it moves down. So the stationary points are there, the 2 of them. So if you try to sketch, you'll get something like that. So that is the sketch of the curve. So you can use the other method of getting the second derivative. Remember the first derivative. The first derivative is here. The first derivative is negative 2x. So this is dy over dx is equals to negative 2x. Negative 2x, 3x minus 8. Which we had obtained this one as negative 6x squared plus 16x. So let's get the second derivative. The second derivative, derive it, that is differentiate it again. This will be negative 12x plus 16. Negative 12x plus 16. Then from there, we can get the first point where we have the stationary point. We have 2 stationary points. One is x is equals to 0, and the other one is x is equals to 8 over 3. So we start with x is equals to 0 as the first stationary point. So x is equals to 0. So this one you substitute, you get negative 12. 0. This will give actually plus 16. It will give 16. So this is positive. What did we say? If it is positive, if the second derivative is positive, then this one is a minimum point. If it is positive, it is a minimum point. A minimum point is like this. Minimum point is like this. Then, if the second derivative is negative, so we can test the other point. The other point is negative 12 x plus 16. Now we've tested 0. We can test 8 over 3. So negative 12, 8 over 3 plus 16. So this one, this will give negative 4, negative 32. This will give negative 32 plus 16, because this is by 3, 1 by 3, negative 4. Negative 32 plus 16, and this will give negative 16. So you can see this one is negative. So if the second derivative is negative, then that one is a maximum. Is a maximum point. So that is another way. And the maximum point is like this. N is like an N. So that is how you arrive to this. So this one is a maximum point and this one is a minimum point. So you can use these points to ascertain that, the nature of the stationary point, or you can use the second derivative. Now, having done that, now we can go to the curve and sketch it. You can sketch it. We have the axes. So it cuts x-axis at 0 and 4. Those are the points, 0 and 4. So that is 0 and that is a 4. Then the stationary points, 8 over 3 and 512 over 27. We put it there. That is a stationary point. Then you sketch it like that. And that is simply how you're supposed to do curve sketching.